And welcome back as we go ahead and continue our look at copies and clones. So today specifically we're going to go ahead and pull apart to try and make that deep copy with clone methods. So the first thing we're going to start off as a quick tip. We want to use a type parameter bound to make a better clone object. Because remember before, when we start looking at those clones, they were very shallow. One way to overcome the problem we have in our previous pitfall is, of course, to place a bound on the type parameter t, so it must satisfy some type of suitable interface. Now, there's no standard interface to do this job, but it's obviously very easy to create an interface. The interface publicly clonable given below is just the type of interface that we would need, and this is one that you're free to use. So we just say public interface, publicly clonable, extends clonable, public object clone. And of course, what we're trying to do with this, we're trying to, of course, to use it to make a deep copy. This short, simple interface guarantees all that we need to define generic linked lists whose clone method is going to return a deep copy. Now, you'll note that any class that implements the public clonable interface has the following three properties. The class that implements the clonable interface, which is automatically going to happen because publicly clonable is going to extend clonable. The class has a public clone method, and the clone method for the class makes a deep copy in the officially sanctioned way. Now, condition 3 is not necessarily enforced by the Java compiler or runtime software, but like all pretty much interface semantics, is the responsibility of the programmer to define the class to ensure that that condition is satisfied. It's not very easy to define our generic linked list whose clone method produces a deep copy, as we're going to see in the cloned linked list class. So let's look at this with an example, a linked list with a deep copy clone method. Now, we've already discussed the how and whys of the clone method of the generic linked list class of how it returns a deep copy. So let's look at some of the other details to see an example of using this linked list class. All right, so let's start by noting the definition of the clone method. Why did we not simply say, hey, public linked list, clone, return new linked list, this? Well, a linked list with a deep copy clone method has, of course, things that we have to handle. So the simple alternative definition that we would like to do is still going to get us a deep copy and would work fine in most situations. In fact, it's likely you would not even notice any difference if you use this definition in place of the one that we gave in clone linked list. The only reason for the other detail is to define the clone method as specified within the Java documentation. The reason that the Java documentation asks for the details has more to do with security issues than it does necessarily with the actual implementation. So the clonable interface is, of course, one of the big things that we're using here. And if you look quickly at clone linked list, you might think the following at the start of the definition is relatively important. Implements publicly clonable. However, by having that in there, it ensures that the linked list class implements the clonable interface. And for a class to have a Java approved clone method, it must implement that interface. It also allows you to make the linked list of linked lists and have a deep copy clone method of the linked list of a linked list. So a sample class that implements the publicly clonable interface, of course, is, for example, stock item, which we're going to look at in a second. And we're also going to look at deep demo, which is going to show a demonstration that makes a deep copy clone of a linked list of objects of that sample class. Now, the thing you have to understand about cloning is that it's really kind of an all or nothing approach. If you define a clone method, then you should do it as it's defined in the official Java guidelines, as we did within the cloned linked list class. You should always have the class implement that clonable interface. If you define a clone method in any other way, you may encounter some problems. Now, if you want to have a method for producing copies of objects, but do not want to follow the official guidelines on how to define a clone method, and then, use some other name for the clone-like method, such as copier, and do with just a copy constructor. So if we look here at our methods and our classes, you'll see our clone linked list here is, of course, extending the publicly clonable interface. And of course, it's implementing that as well. And that's what's going to allow us to use that clone. If we look at publicly clonable, you see it extends clonable, which of course, public object clone, which is what we talked about. And that is going to address that issue of us having to worry about the shallow copy that we had previously. In fact, if we come down and start looking at our methods here, you can see we have a public method clone linked list. We of course have our clone method here, and we don't have to have an issue like we did before. Now, of course, this one, if we look at it, it says, hey, this is null pointer exception. Okay, great. But if we look here at these classes now. This is the stock item, which is of course is implementing that interface as well. One thing you'll see with this one is that how it works, it simply just has an object clone, which is doing a try catch, and you can see it's returning a super clone. Otherwise, it's of course saying clone not supported, which of course it shouldn't happen. We go return null. And we have our deep demo. So this is what we actually want to look at. So how can we actually take these items? So there's our item of our class that we're going to kind of fill in for this interface. Because remember, this is a generic class here because we have the T. All right, and anytime you see that bracket T, remember we're going to clue us in that, hey, this is probably generic. So if we look at our demo, we have our clone linked list class, and we're passing in stock item. Stock item is the type. And we're going to make a list of that. And of course, new clone list stock item. And then we're going to add to it some items. Boom, boom, boom. And then we want to clone this. All right, so we're going to say clone linked list stock item copy list. So notice this is original and copy. And we're just going to call that with original list.clone. And that's the key here for how we're going to go ahead and call this modification here. And then what we're going to do is we're like, well, let's see if they're actually equal. So we're going to do a quick equals test here. We're going to test the first list, the second list, and we say if they're equal, we're going to just save that. Now let's change the copy list, because remember the thing we said before with a shallow copy is that the data is linked. If we had done this with a shallow copy, we would find out that, hey, both lists are being changed. But with this deep copy, when we go ahead and run this, one of the things that we're going to discover is that only one list is changed, because again, they are, even though the lists are equal, their data pieces are looking at two different points, two different references, because we are doing a deep copy rather than that of a shallow one.